Welcome to Engineering Design and Omniverse. We've been gone for a few weeks.
Yeah.
And I don't even know if we're talking about what we were doing yet. So we're just going to pretend like we weren't gone or
Yeah.
so still top secret stuff, but I'm sure it'll come out here soon enough. I try not to be the announcer of new things when I'm not supposed to be the announcer of new things. That's my policy.
Well, but you should still announce new things that are happening in your life, right? Like, what did you do for Thanksgiving? And
That's true. That's a good distinction, right? I should announce new things that are my things to announce, and not announce things that are not my things to announce.
Yeah.
There we go. Okay. So, welcome everyone. Let's see if we're getting people roll. Shout out to us when you roll in. We love to hear from you, and we're excited to talk today a little bit about. We're back to talking about JetRacer. Got my parts all scattered. You may, if you've been a regular, you might have seen that I used to have an extra monitor there, and now I don't. So we'll talk about that. Hey, how's it going, Didi Juggler? Good to see you. And wow, we're getting some people rolling in. This is great. Glad to see you all. And so let's just give a quick overview of what this project is since we've been gone for a little while, and for those of you who are new to this live stream. Right here behind me, I've got the JetRacer. It's a 1/10 scale remote control car. It's plugged in, so I can't. It's a 1/10 scale remote control car, and I've got a Jetson Orin Nano on it in the chips, so that I can control this car either from the Orin Nano or from a classic RC car remote. Okay, boom, leave it right there. And what we're trying to do is we're trying to learn how to train that car to drive itself. But not just that, we're going to teach it to do that inside of Omniverse. So we'll train this in a virtual environment. So we'll train a virtual car in a virtual environment. And once we have that model trained, we will deploy it to the real car in the real world. And we're going to figure out how to get that sim to real gap workflow going so that we can train our robots in the virtual world. And let me just do like a little. I'm going to pull up a little blank PowerPoint here. I just want to show this workflow that we're talking about, okay? Just so it's crystal clear. I want to do here we go. So if we draw this out as a workflow, first we're going to capture reality. Let's say we want to train a robot to drive around a factory floor or a warehouse, okay? What we're going to do is use, it could be like a LiDAR scan from a partner like Preview 3D. It could be some instant nerf technology. There's a lot of different ways of capturing reality. But that's step one. At the same time, we need to model the new. So that means if this is a brand new robot that's never been manufactured, we can make CAD models of it. And so we'll need to, while we're capturing the existing, we need to go ahead and model what's going to be new, right? And those two are going to get merged. Let me see here. Let's go home. Let's get a line going here. And we're gonna get all of that data flowing to OpenUSD, right? And we're gonna in Omniverse is this is kind of the same step, right? Although sometimes you might want to edit this scene in Maya or Unreal or any of these other DCC apps that can connect to Omniverse, right? But this idea here is we're gonna create a USD scene, and from there we're gonna simulate our scenario and use that environment to train our robot.
Yeah, I would almost move Omniverse to where the simulated train is, right?
Oh yeah, I like that. Right?
Yeah.
That's absolutely right. So we're going to use Omniverse to simulate and train our AIs. Also using USD, right? From there, once we've trained our initial model in Omniverse, we're going to deploy to the real world and use our robot in the real world. Now, here's the, let's see, let's get these all, oh dear. Oh dear, now we're.
It happens.
We got to attach these here. Now they'll move a little better. There we go. Yeah, that was attached. Very good. Now, this is where, up until now, someone could argue, like, why are you doing this virtually? I think someone could argue. I would argue back, even at this point, and say, because it's going to save you a lot of money, right? Because it's a lot easier to train a robot in a virtual environment where you're not going to be paying for repairs.
I actually liked the example you gave the other day about space.
Yeah. What was that? I don't remember.
You were saying if you wanted to train a robot on space, that's so hard to do, right?
Yeah, you just can't, right?
It's so difficult. You would have to make sure that gets there to like the moon or, Mars, wherever you're trying to get it to. And it's like, once it's there, then it's like, okay, now the training stuff starts to happen.
Yeah, send a command and wait for like a minute before it does one thing, and then it gets back. Yeah, absolutely. Yeah, space is one example where right now, this current workflow, as is, would save you, I don't even know how much money, right? It's just not possible, I would say, without some simulation. And there are clever ways they simulate today. Like they have these 0G labs where they have a robot arm. You can attach your object to that arm, so it acts like it's in 0G, and so you can kind of have all these items attached to robotic arms that are in simulated 0G, and you can train them there. But they are such expensive labs. So I think Omniverse is going to really help out there. But let's say you get a bug. Like, let's say you're training robots to carry packages around a warehouse and move them around, and two of your robots hit each other and crash and break two of your robots. That's awful, right? Well, right now, if you wanted to train for that scenario, you'd have to get two real robots and send them at each other and hope you can reproduce that crash bug, and then train them not to do that with real robots crashing into each other. I guess maybe you cover them in foam or something, but I don't know. I think it would be untenable, right? So what you do when you have these bugs now, with this synthetic data scenario, is you find a bug and you capture it. You capture that bug, you model it, and then you add it to your data you're training on. And that becomes like a unit test, so that any new models that go out, they're trained on this new scenario, And you can even make sure they'll pass that scenario before you deploy that new model to prevent regressions. And this classic kind of CI/CD workflow becomes possible if you're using synthetic data. And I just don't know how you do that in the real world, especially when you get into some of the more touchy scenarios, like with autonomous vehicles and pedestrians. We want to test those. We don't want to test those in the real world. We want to test those with synthetic data, right?
Yep.
So,
definitely don't test them in the real world. I've seen some very interesting things that happen when that occurs.
So I just got that image. Have you all seen Hot Rod, where he has a suit and he has a van hit him while he's wearing a big puffy suit?
Yeah.
That's what I have in mind. All right. So this is our workflow. And keep in mind that this is all very flexible. Like Omniverse is a platform. This could be a custom app. This could be a set of extensions in Isaac Sim. This could be, I don't even know what, right? The USD scene, this doesn't have to be done in Omniverse. This could be, you could model this in Blender. I mean, modeling the new, if it's a functional thing that needs to be manufactured, yeah, you're probably going to want to do that in CAD. But in my case, for training this to go around a track, I'm going to need some cones. And those don't have to have the right mass properties or anything. They just have to look good. So I think Blender might be the better solution there. So each one of these blocks could be fulfilled in any number of ways. And I hope that you who are with us see that as an opportunity as tool makers to build your business, right? Because if one of these blocks sounds the most interesting to you, you can build your tool to fulfill that need, and it will fit into the ecosystem. You don't have to worry about the rest of the workflow because other people are making tools for that. We have partners who do reality capture. You can hire people to do CAD for you. There are so many CAD tools out there, right? But maybe those could use, some preset models or libraries. Each one of these blocks is full of opportunity. So, tool makers, find the block that's most interesting to you, and I hope that you'll start working on that. And,
just to, a little bit adding on to that, if you're not a modeler and you're more into the programming and simulation side of things, we do have asset providers that have free assets if you want to get a cone or other stuff. Or you can even use some of the assets that we've already have that we've kind of went over through GTC, talking about some SimReady assets. And just pulling up any scene, right, and then just using that can get you started, right?
Yeah. Papa Chuck, what if it really is a bug? Yeah, I'm sure that'll happen too.
I mean, you got to learn from mistakes, right? Nothing's perfect.
Yeah. All right. So that's our workflow we're working towards. And, but I think the first step, and one thing I'm learning is if we can find pockets where people have done a lot of work already, that's a great place to start, right? We want to align with existing groups who are doing work here. And so the ROS, so we want to, let me get there. Sorry, I'm kind of trying to explain where we're at. Okay. So now, Isaac ROS, let's talk about that now. When we talked a few months ago, we were not going to use ROS because my intelligence, I kind of collect intelligence and try to get a feel for what people are using out there. And my intelligence was telling me that the enterprise customers, the ones who will pay you to do things, were not so interested in ROS, right? They liked to do things a little more from scratch or with other libraries. That there has been kind of the winds have shifted, and my intelligence now is telling me that they are using ROS, that enterprise customers want to use ROS, that most people are using ROS. And so we're going to make this paradigm shift from doing things more from scratch to using ROS. And as Janiscu pointed out, we'll be using Isaac ROS. And if you're not familiar with Isaac ROS, don't stress. Isaac ROS is there. It's like an API, and I'm just learning myself, but my understanding is that it's essentially a second set of ROS libraries you can use, and they have the same function calls as your typical ROS library. The difference is that your typical ROS library runs on CPU, and the Isaac ROS library runs on GPU. So basically, you can follow any of your ROS tutorials or take any ROS code that you've used, and you should be able to find any bottlenecks, find calls that are available from Isaac ROS, and then just do a direct substitution, and then just kind of easily speed up your code base. So that's what Isaac ROS is. And not only that, one of the things we were working on before was writing these extensions and kind of figuring out how do we emulate and create a package that we can run on our workstation, but then we deploy to the JetRacer. Well, it turns out that the Isaac team has been working on that for Isaac ROS, and well, actually not just for Isaac ROS, but for ROS. And there is what's called the ROS 2 bridge for Isaac Sim. And so essentially the way that my understanding is, and we're learning together here, so I might be wrong, I don't think I'm completely wrong, but I might be a little off, right? Is that the ROS bridge is essentially, you could think of it as an Omniverse connector, so that you can treat Omniverse as your robot and send messages back and forth to a ROS package. And so you can basically, you've got your ROS app running, and it's receiving camera feed and sensor data from Omniverse. It's processing the same way it would on your Jetson, and it's sending your information back to Omniverse so that you can respond to it and make your robot move the way it would in real life. And so with the ROS 2 bridge, we should be able to create a ROS package that runs on our workstation and then is a direct deploy to the real world robot. It works the same way. Super cool. And so with that in mind, I think the first step we want to take is to just get ROS 2 working, and we want to get the real car working, because there are tutorials. There's a lot of information on doing that. It should be a relatively achievable task. And then once we've got that going, we'll reproduce that effort using the ROS 2 bridge in Isaac Sim, and we'll just get a car working in the virtual environment. And then step 3 is we will take that model that we've trained in Isaac Sim and learn what it takes to deploy that to the real world and get it to work, kind of cross that sim to real gap. There we go. How does that sound? Good. Okay. So with that, let's just walk through how to set up the Jetson. Great comment from Zia. ROS handles all the communication between components, keeping in mind that everything has to happen in real time for a microcontroller. Yeah, essentially. So let's see here. I've been doing this. I've been working on this this week, and let's start pulling up some websites here. Just a second. Here we go. First, Jetson Orin. This is a great page from the NVIDIA documentation. Right here. This is your getting started guide. And I'm going to go ahead and post this link into the chat. So I've got my car built, And I suppose for that, let's just go to the JetRacer. So, by the way, both the JetRacer and the F110th are such similar platforms. At this point in the way we're working now, I don't think it really matters if you want to build a JetRacer or an F110th car. Well, keeping in mind that we're doing a camera, so if you do the F110th card, just don't get the LiDAR. Great. Okay, let's just a second. Can we make this a GitHub open source project and we as a community can develop together? I would like to do that. I have to go through our legal process before I can make public GitHub repositories. But I really like that idea. And so I'm going to try to make that happen on my side. I can't promise until I've gone through the legal process. So, and a lot of that has to do with there are some mistakes or some things we could do very easily that would cause legal headaches. For example, there are open source licenses that would require if you use some of these open source licenses, which ones are the tough ones? It's what's that?
It's also just more so that we're not accidentally giving out information that shouldn't be.
So there's a few legal gotchas we got to make sure we're handling well. There you go. All right. Okay. How much does that car cost? Great question. And by the way, we're using the Aura Nano, but you could use a previous Nano, and this process would be a little different, but would still work. And in fact, Jen does not have the Orin. You have the Nano 4 GB. Is that right?
Yeah, it's not the Orin. It's the other one. That's the cheaper one. Not the $500 one, but the $200 one, or the $150 or something like that. So I guess, it depends on how much you want to spend. I think I spent a total of, how much was that? Like $400, $500, and then
I think you spent $400 or $500. And by the way, you just bought yours off of Amazon, right?
Yeah.
Shipped. So she bought it. It came with the Jetson. Came shipped to your house. So it was really, really easy.
Yeah.
And then I went to the hobby shop and bought this Tayama TT02. I bought an Orin Nano, which is an upgraded Jetson. I bought this controller. I'm into this about $1,000, but I also spent some money where I felt like doing some upgrades. I think you could do this build for like $600. And then the F110th car without a LiDAR, I think you'd be in it about $1,500. But then you've got an off-road car, a little bit better, more robust setup. And that's what the Orin. And by the way, if you go to the F110th site, it's going to recommend you use the original AGX. So not the Orin AGX, but the previous AGX. And the Orin Nano is more performant and it's less expensive than that previous AGX. So don't get the previous AGX, get the Orin. And all the F110 folks nowadays are using the Orin. Either it could be the Orin Nano or the Orin AGX, but they're all using Orins. Yeah, great question. Let's just keep going through these. Yeah, so what? That's a great idea. Would be to try to get a simple joint working in ROS, then bring that into the real world as a twin, higher iteration versus making a whole car in sim. Yeah, so like we could make a little simple single joint bot. So it could even be just no feedback, but just make a pendulum go back and forth, or make a crank slider go like we've done. And if we want to work on, if some of you want to work on that kind of hello world project, I think that'd be great. We could work on that together. And theoretically, you can do the same with any car that uses I2C. Yeah. That's we're trying to standardize this platform as much as we can. And so I think there's a lot of flexibility here. And then let's see here. Lots of great questions and comments. Let's see.
Yeah.
It'll be helpful to have someone from the legal team to explain how developing alongside of existing Omniverse code works when it comes to commercial use. Well, I can tell you that when it comes to the extensions, you can look at the licensing agreement. And so and that's why we're so careful, honestly, is when we release things, we want you to be able to use them. And I think if you go to any of the NVIDIA GitHub repos, you can look at the license, and it'll typically be an Apache license, which means you're clear to use that for commercial use. But sometimes if you look, there'll be a specific NVIDIA license. And this is less common, but keep an eye out for it. If that's the case, then there'll be terms for how you can use that commercially or not. And then there's I can't remember the name of it, but there are these other open source licenses that basically say any code you write, if you use these libraries, you have to make that with the same open source license, and you can't charge for it. And you want to typically, for commercial stuff, you want to avoid those licenses. Now we're talking. I like the way we're thinking. I want to clean the kitchen and bathroom robot. Can we add laundry to that list, please?
I mean, you could just get a Roomba.
Roombas do laundry?
No, but they can clean the bathroom and the kitchen.
Okay, then hey, new I don't know this guy, but welcome, Ya Hydra. Hope that's not Hail Hydra from are you like a supervillain? I hope not. Like Hydra from Marvel Universe? No?
They might not even know.
All right. Are there any docs for installing ROS 2 nav 2? I do not know because we haven't done that yet. So I'm sorry, but we're brand new to ROS 2. We've just made this paradigm shift, and we're all in. But what you can do, the Jetson forum page on the NVIDIA forum is very active, and the Jetson folks monitor that forum, and so I would go there and ask. So let's see if we can find that. Jetson NVIDIA forum.
And then if you don't get your answer today, highly recommend to join the Discord. There's a whole channel for JetRacer too, so you can always stay up to date on certain things that are happening, or if you need to reach out to Eric or myself, we are also on there.
All right, here we go. Let's see. Are you using a CAN bus for talking to motor drivers? Let's see here. I don't want to unplug my Orin, and it's a little bit tethered. Let's see what I've got here. I'm not. What I've got here. Let's see. Can you make me big here?
Oh, yeah.
There we go. I've got the Orin Nano. I've got my motor driver, which is what, I26. Is that what they're called? I'm still kind of new, but it's that lettery, numbery, pretty typical motor driver. And then this is a MUX, but it's essentially lets you handle multiple inputs to the motor drivers and switch between them. So as you can see, I'm pretty new to this. I'm learning. I can't remember the names of things yet, but I remember what they do. And then this is my radio controller, my radio receiver, excuse me. So I've got my radio transmitter, or my Orin through this driver, either one of those can control the car. And they route through this chip that lets me choose which one is in control. And that's so that if my autonomous setup is going off the rails, I hit a button and it like take control of the car before it wrecks, I hope.
Yeah.
Yeah.
Zia did bring up a good idea. If you guys have like certain specific questions towards like Isaac Sim or like things, because we're trying to kind of do this as we're going, and we're with everybody here. We're learning step by step. I don't think Eric and me are professionals or are fluent in ROS as the Isaac Sim team is. They do stream, have a weekly stream. They have office hours, so if you want to ask any like super detailed specific questions, I would highly recommend going to them. If you want to kind of sit and watch us go through the steps, kind of like how Ashley does her learn with me's, feel free to stick around, and then maybe you can watch us fumble a little bit and stare at the computer like all dumbfounded. But yeah, if you need those questions, highly recommend doing that.
Yeah, great point. And is that every Tuesday morning that they do that?
It was every Friday morning.
Oh dear.
It could be Tuesday morning. I could be screwed up. They did do it Friday mornings, but it's probably Tuesdays. But that there is the ad event calendar.
If only Edmar were here. He knows this stuff. He knows what all of the streams are. Let me just schedule shows Wednesday. Great. So Wednesday mornings, and they alternate between Isaac Sim and ROS, and Isaac ROS. And yeah, absolutely. And I think another little tip or announcement is that on December 20th, we will have Stephen Gong on the standard Omniverse live stream on Wednesday, December 20th. If you don't know who he is, he's a researcher who trained an F-110 car to drive around a building on his campus with really kind of highly optimum routes, and it's this really cool video. And we're going to have him on we can do a Q&A and talk about how he did what he's did, and just talk about ROS and robotics and what he's done. So it's going to be really cool. So we've got a lot of robotics stuff going on. With that, let's step back to the Jetson. Let's see. Did I share the JetRacer repository? I don't think I did.
It doesn't hurt to share it again if you need be.
Yeah. So here is the JetRacer repository. This has a bill of materials. It has tutorials, a lot of great stuff for this car. It does not use ROS. It uses Jupyter notebooks. That's okay. It's still great to get you started. All right. And so I've shared this page. And so what you do here is you write. You'll need to get yourself an SD card for your Jetson. Oh, where'd my reader go? And you'll need to get a little SD card reader. Nothing fancy. Thanks, Zia. And then what you'll do is you'll follow these instructions step by step. They're very clear on how to. Does it show where the image is? Here, right here. The Jetpack SDK page right here. I'll share that too, even though it's in the Getting Started tutorial. So this has Jetpack. You want 512 for now. And you'll save that you'll write that onto your SD card. You pop it in, and then when you power on your Jetson, you'll want to, the first time it's easiest, I think, to plug a display and a keyboard and a mouse in. It's got an HDMI port and 4 USB ports, so that's really easy. And then you'll do your first time setup of it's Debian. So it's just you're just running Linux on there. It's not too bad. And yeah. And so once you have that running, let's see, you'll want to do this step, enable SSH. You'll want to go into the SSH config, and then there's going to be a line either that says password authentication no, or it'll be a commented out line that says password authentication yes. And you'll want to either change that to yes or uncomment it. And I'll paste this link. And what that does is it lets you SSH into the Jetson over your Wi-Fi network. And log into it. So see, we've installed Debian. We've configured SSH. You'll set up the username and password when you when you first log in with that display and the keyboard and mouse. And then after we've done that, there was one other step. What was it? Let's make sure Chromium's installed. Well, you don't have to, but that's nice. You'll need to go, if you're on Windows system like me, you'll need to install Windows subsystem for Linux. I like WSL or WSL. I like WSL too. I think most people do. I would recommend that one. So let's go to, I'm going to go ahead and launch that on my computer. So it's initializing. Here we go. Oh, what you'll need to do, the other step, it's a simple one, is you run ifconfig. So you go to your terminal and just ifconfig. And ifconfig will tell you the IP address.
Mm-hmm.
And you want the WLAN 0. It'll list like 4 or 5 IP addresses. You want the WLAN 0 IP address. So let's see here.
And this is to essentially connect it over Wi-Fi, so you don't have to have the car plugged in.
Exactly.
Yeah.
So now, I can run SSH. If I just do this, SSH is username at IP address. I'm now logged in with a shell to my JetRacer. Cool, right? Now I can exit that here. Now I'm back on my computer. The next step is I want to show the camera. So there's this great tutorial. Jetson Hacks is the man. I haven't gone through this one yet. This is a tutorial on how to install ROS 2. Unfortunately, it does Foxy instead of Humble, and we need to use Humble to work with the ROS 2 bridge stuff later. So we'll cross that bridge later. But I'll go ahead and share this link. This is a good one. I'm sure we'll use it later. Okay, so now this is a great tutorial using the Jetson Aura Nano with CSI cameras. This talks about basically, that's an important component, is I have a camera on here, and you want to buy like an Arduino style camera, and it has the wrong connector to connect to the Orin. But this video, did I share it yet? No. This video and tutorial show how to fix that, how to get an adapter connector on there. And he has a repository with a Python script that will display the camera for you. And if we try to do that right now, it doesn't fails because SSH is just a terminal. It can't show any graphics. Turns out Jetson Hacks has this other cool tutorial that shows how to get graphics apps to run over SSH. Great stuff, guys. And so and all you do for that one really is you do this add this X argument. And the X argument lets you run graphical apps over SSH. So now I'm shelled in. And if I say Chromium, I've been having some problems with the Chromium browser, but I don't know why it's not working right now. But it should work with this other one that's more important. But basically, the Chromium browser, this would when this is working, and I've got to figure out why that one specifically isn't working, but it will just launch a window with that app in it on your computer. It's really cool. But let's use that for the one we actually care about. I have this source folder already on my system, and I've already cloned his repository, CSI camera. All you've got to do, Jetpack comes with Git installed. So you would, if you didn't have it yet, you just say Git clone, and then you would just paste the link to his repository right there. But if here we are in CSI camera, and he's got this simple camera.py script. So we'll run that using Python 3 simple camera.py. Oh gosh, typo. And over here, we have the camera of the JetRacer. A little bit of lag.
No.
There we go. Hey guys, the camera's working.
The lag is pretty funny.
Yeah, I mean, we're going through a couple of steps there, right? But he has these other ones that are kind of cool. Let's see. Let's do Python 3 face to text.py. And I just hope it works here. It should have my face in a blue box with my eyes in green boxes. Is that working? Did it work? Yeah. Let's see here. There we go. Cool, right? So now we've got Jetpack installed on our Orin, and we've checked that the camera is working. It is. We can, if we wanted to launch a graphical application, it will launch from our remoted in computer. So that means that you can, you can have your laptop connected to your robot and control it from your laptop, no problem. And SSH, this is just maybe a little warning that I was a little bit. I'm coming from a Windows background, and so to be honest, the terminal intimidates me, and SSH, and this idea of working completely from SSH, I'm like, wow, you're just going to work over the terminal? That just seems kind of hard. But when you're working with Linux, I highly recommend you embrace the terminal, because that's what they're all doing. And a lot of stuff is really slick in the Linux terminal that would not be slick in like a Windows terminal. Maybe it is, and I just don't know. But yeah, it's really easy to install things and work on the computer from the terminal on Linux, and that's what all the tutorials are gonna do. And so as I've embraced the terminal, that's gotten a lot easier to find information and learn how to do things. So, and one of the mistakes I was making is I was trying to do a remote desktop into the Jetson so that I could use the mouse and kind of use the terminal and avoid the terminal. And I wasted a lot of time on that, and it never worked very well. And now SSH is already working a lot easier and better for me. Yeah, and this is where I was at. So Data Juggler says, I have never been a command line fan. And, I've struggled with it myself. And I just think I highly recommend you embrace it for working with robotics. And keep in mind that you can have these graphical apps. You can kind of keep it to a minimum. You've got the shell. And I'm not doing complete command line. I'm using the command line to launch apps, right? To install things, to launch apps. I'm doing the more straightforward stuff. I am also using it to edit text files, which is a little bit clunky still to me. But even though it's a little clunky to me, all of the tutorials do it that way. And so if you just embrace that too, you can follow the tutorials step by step. And it's not so bad. Here we go. So we've got 15 minutes left. What should we do?
So
should we dig into ROS a little bit? Just learn about it?
We definitely can. We could just start it. It won't be finished, but we can start taking a look.
Yes. We're going to start taking a look at. Let's do that. And I'm going to go ahead and exit my Jetson. Oh, this is interesting. Port tunneling forwarding is a very cool thing to learn about SSH. Yeah, no doubt. And I've got to say, I had struggled with the command line, but it's like Linux is made to be used from the command line, right? So many Linux users are command line users. So really I'm becoming more of a fan. So especially on Linux. I don't think I would start using it so much on Windows, but on Linux, definitely seeing some value there. And definitely still recognize that I have a lot to learn. But with that, let's take a look. Let's just see what it takes to install ROS on our Jetson. On Orin. We want to. I find if we say Jetson, we might get some old articles. Install ROS 2 Humble on Jetson Orin. That is exactly what we want to do.
But it's a question on Reddit.
Yeah. Well, hopefully somebody answered it, right?
They might have not.
This is an Isaac ROS one. Docker files and scripts for development using the Isaac ROS suite. Okay. This seems good. ROS 2 Humble on 2004 Focal. I don't know what version of Ubuntu. We are on Ubuntu or on Debian? Are Ubuntu and Debian? I'm so new to Linux. I think I said Debian, but I don't actually know for sure. Please visit the Isaac ROS documentation to learn how to use this repository. You got it. Let's see. I'm just curious, has anyone who's watching, have any of you installed ROS onto a Jetson? This is quite recent. So, All right, let's just. All right. Okay, on Jetson platforms, Jetpack manages all of these dependencies for you. I wonder if Docker already comes with Jetpack to start with. Well, this is a container. Looks like we're getting into containers, aren't we? So I think we're not going to get there right now. So I think I'll just explain what a container is for 5 minutes, and then we can answer any questions and kind of continue on next week. So let's see here. Let's talk first of all. You've got a physical computer that you're familiar with, right? You got a physical computer with physical hardware. You got your CPU, your memory, all of that. And at some point, someone said, "Hey, it would be nice if we could use one physical computer for more than one computer functionally," and that becomes a virtual machine. So, what a virtual machine lets you go into that computer and kind of divide it up. So you could say, I want to use half of the memory for one virtual machine and half for the other. And same thing with the CPU resources and all that. And you can divide up a computer into multiple virtual machines. And there are a few problems there that people ran into. One was, what if you want some flexibility with how much resources you're using? And with the virtual machine, you have to kind of preset how much resource you're using for each virtual machine. And two was, when you're deploying software, different virtual machines on different computers, they have different operating systems, they have different hardware, they behave differently. So you end up with a lot of bugs and issues, and it's difficult to test. And so someone came up with the concept of containers. And a container is in some ways similar to a virtual machine, but a container is kind of, you take and you package everything that a virtual machine would need. Those are the operating system itself, any dependencies, and that's all packaged together. And so then when you run, and then you've got an app such as Docker. Docker's not the only one, but it's quite common. Docker runs you can run Docker on your computer, and Docker handles any communication between the Docker container that you've got installed, which has got its own operating system and everything, and your local computer's operating system at the kernel level. So it's communicating at a very low level to whatever you have installed. And because it's communicating at that low level, and because you're running an entire operating system in that container, and because it comes with all of its dependencies packaged, that Docker container will run kind of just the same on any system it's installed on, and it only uses the resources it needs once it's launched, and just kind of uses those resources on demand. And so containers add that flexibility to virtual machines, and they're really cool. And I'm learning about them as well, because it's all part of this ecosystem. But yeah, that's what a container is. Does that clear? Kind of a clear explanation, Jen?
I think so.
Okay.
But if anybody has questions, please feel free. We still have about 6 minutes.
And Shaheen, this is great. Jetpack has Docker. So it looks like we'll be using a Docker container. And in my experience, using Docker containers is really nice once you get going. It's pretty easy because it comes with all of its dependencies. It's like if you use it without Docker, you've got to like, you go to install one thing and it depends on this other thing. So you've got to install that, and that depends on this other thing. So you've got to install that. And it doesn't work on your system because you're configured wrong. And so you've got to change your config. It's like this big old dance, right? But when it comes to containers, you just pull the container and it works. It's great. Authoring Docker containers, on the other hand, is definitely an art, and a valuable one, and worth learning. And I am learning it, but it is not so easy. And then even above that, automating containers is a next level. And so people do that too. So there we go. With that intimidating note on learning how to write and automate Docker containers. If you have any questions, happy to answer. But I think I'm going to try to end without a cliffhanger today.
That's a good idea.
And for next week, I'll be digging in to ROS, and hopefully by next week I can show you how to get one of those ROS containers pulled and running on your Jetson. It shouldn't be too bad. It's probably going to be, it's going to take me a minute to learn it, but it's probably going to be like start Docker, pull ROS2 container, and then it works.
Yeah, you know what? Maybe you can collab with Papa Chuck. He can help you through it.
Yeah, that'd be great. Yeah, next week, going to dig deeper to ROS on the JetRacer. That's right. Oh, when you started EDAO, I said you can't escape containers. I can escape containers easy. Look, you just type exit, EXIT, and you escape the container. I don't know what you're talking about. Well, with that, we'll see you all next week.